All right, so thanks for coming to this election night. It's pretty cool that somebody show up, so it's already good. So my name is Jacob Jedrzejczyk. I'm a software engineer at Microsoft. You can find more about me on my blog, jg09.net. This is my personal blog. I mostly blog about things I'm doing after work, but also like about some cool stuff we are doing during the work, because my work is pretty cool, because I work on the Azure Management Portal, which is one of the largest web apps in the world. We have over 500 engineers working only on front end, and thousands of engineers working on the back end, because it's an entire Microsoft cloud, a lot of dev power there. And I did a few talks about how the Azure portal is built. You can find on my YouTube channel, or it's also linked on my blog. And then I live in Seattle. Is somebody not from Seattle here? One, two people? Okay, cool. So where are you guys from? California and Florida. Whoa, it's totally different part of the world. Yeah. So if you're here, really recommend you to go check out the area. It's amazing. And actually now you have a pretty good weather for this time of the year, because usually summer is awesome and winter is it's like the time when you can really focus on your work and don't leave the building. So yeah, it's really amazing. And if you're doing biking, running, or swimming like me, and you're doing triathlons, this is like the best place to be. So so really recommend you to take advantage of that. But let's talk about F#. So how many people here already know F#? Okay, 2 people. Okay, great. So F# is cross-platform. You can use it on Mac, you can use it on PC, you can use it on Linux. On Mac and Linux, you can run it on Mono. And F#I is interactive command line for F#. F#C is a F# compiler. And on Mac, you can use VS Code to work with that. And there's a pretty cool plugin called Ionite for F# support for VS Code. And on PC, you can either use VS Code, or you can use just Visual Studio. It's a very, very good support for F# there. So let me show you a little bit of F#. So I'll open my command line. And I'll open the F# interactive. So here I have my REPL. You see I'm using 4.1. So if I want to declare a variable in F#, I just do let x equals 2. I need to end my statement with 2 semicolons, which is like a little bit uncomfortable, but I'll show you why. So here I have one variable. If I want to add 2 numbers, of course I can do 1 plus 2. This is it. What I can also do is I can create the functions. So you create function pretty similar to how you create variables. So let's say I want to create a function that will calculate the square of the parameter, and then I can call it, let's say square 2, and it gives me 4. One thing about the variables maybe, so like when I have this x, right, it's equals to 2. If I try to change it, let's say to 10, it will return me false result. What that means is that x actually wasn't changed, because by default in F# the variables are immutable, so you cannot change the value. If you want to change the value, you need to say mutable y, say equals 1. So now y is 1, and if I want to change it to, let's say, 10, I need to use this very uncomfortable assignment sign. And then it's changed. If I use equals, let's say 20, it will still not change it. Why they want you to use this very uncomfortable assignment sign? Because in F#, F# is based on immutability. So if you need to change some variables, that means you're probably doing something wrong. So they want to make it like very, very obvious for you that you shouldn't do it, but you still can. All right, let's do some other stuff. So I have this function square, right, that gives me a square of 3. If I want to create a function with 2 parameters, let's say to multiply I can still do it inline. Say multiply 2 and 3. And you see I don't need to use any commas. I don't need to use any brackets. That's pretty cool. What I can also do, I can create a function cube, and we'll take x. And first, I'll need to square my x. Then I can use pipe operator. I will pipe the result to the next function, which will be multiply. And the first parameter of the multiply will be this result of the square x function. And the second one will be x. And then if I say cube 3, I get 27, which is 3 times 3 times 3. You can also find functions you can use more than one line in functions. So let's say a function f that will calculate the factorial for me. And then if I say if, oops, sorry, actually I did it wrong. One more time, f that takes parameter is, actually let me call it factorial to make it a little bit more obvious with one parameter. And here I say if x is equals 0, then return 1, else x times factorial x minus 1. And I get the error saying that, hey, I don't know anything about factorial. And what you have to do when you create the recursive functions, you need to add this keyword rec, which is pointing that this function will be recursive. So now it doesn't complain. And let's say I'll calculate factorial of 3, which is 6, or factorial of 4, which is 24, or 5, it's 120. You know what will be 6? Anybody? 720. Yeah, okay, I'll stop here. Just kidding. Yeah, so so this is how we create the functions. Of course, you don't have to work with REPL all the time. Oh, by the way, like when you start with REPL, the way how to exit REPL is actually harder than exit Vim. You need to use # and say quit. Like there's no way to exit with Control-C or Control-D. Actually, I have Control-D hooked up to some keyword that creates multiple consoles for me. So so that's not a problem. Like Control-Z, like nothing works, and you try different things, and then I have to Google and find out that it's quit, and then you can exit. So let me get. You can also create the file. So let's say hello f#.fs, because it's not C#. And here I will say let name equals Jacob Bedrzejczyk. Oops. My needs are marked. And let blog equals jj09.net. And print function. Hello, my name is string, and my blog is at string, and I pass my name and my blog, and I don't have to use commas. I save this file called hello F#, and I will use F# compiler. Hello F#. I'll compile it, and it will produce for me the exe file, which I can run. And I have the same experience like with C#. So this is F#. The very cool website to get started with F# is tryf#.org. Didn't visit this site for some time. So here you can, if you click learn, there's like getting started with F#, and you have like this interactive tutorial. And here you can, they are giving you a your system does not support. Oh yeah, that's why. So because I'm using Chrome, which is not always the best choice. This browser is much better. You see, it probably will work here. Come on. Loading. Yeah. So here, click beginning, and it's telling me like, hey, yeah, create this, load and run this. like 3 plus 4 and 7, and then I can say, I can modify this and run this again here. So yeah, you need to use Internet Explorer because I think they're using Silverlight to run this. So, but this tutorial is very, very cool because you start like from the beginning and you go to the more advanced features. Okay, so let me go back to presentation for a second. So the second part of the talk would be about.
Before you move on,
Yeah.
if anyone wants to learn F#, there's a fabulous website called F# for Fun and Profit.
Oh yeah. Yep. Yeah, for fun and profit, yes. At the end, I have a list of bunch of resources for F#, and this is one of the sites there. I think this one is for like people who are doing like a second step, right? Because there's like a bunch of materials how to apply it in different fields. But yeah, there's a lot of different materials here, a lot of examples, a lot of explanations why F# and what is good for. But yeah, thank you. All right, so machine learning. So that's like the second part of the talk, which because I will get to, I'll show my side project. I started with F# and machine learning, but like quick intro to machine learning. So in machine learning, the two main techniques is supervised learning and unsupervised learning. Supervised learning means, hey, this is like the bunch of data, and this is like a set of rules, and please figure out things for me. In unsupervised learning, you're just giving a bunch of data to the algorithm and telling the algorithm, hey, please find some patterns in this data. For example, some anomalies, stuff like that. So of course, unsupervised learning is a little bit harder. And in supervised learning, which we'll focus today more, there are two main categories of problems that it can solve. The first one is classification problem, which, for example, is when you answer yes or no for some question. Like, for example, I have a bunch of data about customers who are buying Macs and PCs. And then I have like their age, where they come from, and education, blah, blah, blah. And based on this data in classification problem, let's say I have all this data and I have like a new customer and I know all of his like education, where it's coming from, so on and so forth. And like, please tell me, will he buy PC, yes or no? So the classification will classify this customer. So which is very useful for retail. Regression problems is a little bit different. So sample regression problem might be, for example, like, hey, how much cost the house with given square feet? For example, you have a bunch of data about that. But some houses that are 1,000 square feet, some are 2,000, 1,500, so on and so forth. And then let's say, okay, so how much it would be to buy like house which is like 1,800 square feet, right? And then using our regression algorithms, you can like more or less figure out in what range this house will cost. And if you want to learn more about machine learning, I really recommend you to check out the Coursera. There's a course created by Stanford University. It's very, very high quality. It's very good. I'm actually going through it right now. It's pretty cool. And there's also a very cool artificial intelligence course by Peter Norvig, who is research. Currently artificial intelligence is almost equivalent with machine learning, because one of the artificial intelligence methods that are used mostly today is called deep learning. And back in days, I don't know if you guys remember, like, for example, the translators, they were terrible. Like, you're trying to translate some sentence and it just didn't work. And the way how they work, it was they had data and they had a set of rules. So they were rule-based. But in deep learning, your approach is different. You have examples. So you have examples of translations. So what Google is doing, they actually search entire internet, finding, for example, you know, translate English to German. They find entire internet, hey, find me like this sentence in English and German at some website. And then, you know, of course, reject the bad translations. And if you see that, oh yeah, like 60% of translations are saying this, so that's probably the right way. And that's how the translator works now. And it turned out very unintuitively that this approach is better. So that's what now almost everybody is doing. This is what Google Translate is doing. This is what Google Image Recognition is doing. Microsoft Cognitive Services, they also using deep learning. So now machine learning, artificial intelligence are very, very similar. So, yeah, recommend you to check it out too. Oh yeah, and of course, the machine learning is hard. So for example, the Google algorithm, which classified the websites, like what are they about, right? So there are like 5 examples, and like they classify who represents, they classify it correctly. The therapist finder was also okay. Experts exchange as well. But 10 islands, they didn't classify it correctly because probably people don't use hand that often anymore, and there's more of other stuff in the internet. And the speed of art, they also classified it correctly, which is pretty impressive actually. So what I mostly want to talk about today is my overnight project called Stock Estimator. So this is upgraded with F# and a little bit with help of Azure Machine Learning to predicting future stock prices. So what I'm using in this project is mostly linear regression. I'm taking the historical stock prices, and based on the history, I'm trying to estimate how the future will look like. And you can find the code on my GitHub account. It's github.com/jg09/stockestimator. And I just added some fixes yesterday. So everything is up there. And I'll open it. So here's my project. Let me actually close everything for now. Close my tests. So what I have here, I have my logic project where the actual algorithm lives. I also have a web API that is exposing this logic. And I have a web UI, which is calling this web API because this web API is some sort of microservice written entirely in F#, and the web UI is written in C# and it's using Aurelia framework. So in this way, I just want to show how you can use F# without going fully F#. You can just create one simple microservice with F# while your entire stack is like still C# or Node.js or Ruby. So these are the 3 main projects, and I have also tests for that. And here I have also a console app where I'm showing how we can use F# from C# project. And actually, let's take a look at that. So like here I have this logic project called stock data. And in console app, I have a simple console program. A bunch of code is commented, but don't worry about that. So here I just referenced this project, and I just say using stockestimator.logic. And here in oh, it's still good. Oh, yeah. Oh, okay.
Thank you.
All right, cool. So here I'm just calling this function, and it looks like almost as a C# project, right? You don't even see that this other reference library is using F#. So let me go to this logic app. It actually has one file called stock data, where I'm using F# data provider, and this is a very cool thing in F#. So what F# data providers are doing. So here I have a data provider called CSV provider, which means the input of this provider's CSV file. So this link here, I copy it and I paste to the browser, it will return me a CSV file with historical stock prices for MSFT, which is Microsoft. And here you can see there's a bunch of columns and data. There are different columns here, right? So what the data provider is doing for me, it's parsing this, and behind the scenes, it's creating strongly typed API for me. So then, for example, in my function get stock data, what I am saying, hey, load stocks for me from this endpoint. And here if I say for row in stock data dot rows to row dot, and here you can see I have a strongly typed API. I didn't have to create a classes for that. F# did this for me, which also means when the API will change, I can have compilation error in the future, which is pretty cool because in C#, in order to do something like that, you usually need to generate your classes with Swagger, and then you have to regenerate it all the time when you want to update this, right? But with F#, I get this for free. So this is pretty cool. So what I'm doing here in this project, I have some helper functions to generate URL for me. Here I have just another function to get historical stock data, but for some range of dates, not for entire time. And here I have the main algorithm where I'm getting the estimated price for specific date in the future. So the first parameter is the symbol of the stock. It's called ticker. That's how they call it at Wall Street. So I just stick with the convention. For date is the date for which I want to get the estimate. So it's some date in the future. And from date is saying how long I want to look back. And here I'm getting this stock data rows, and then I am calculating first date because to make it a little bit simpler for linear regression algorithm, I am sort of mapping every date to 0, 1, 2, 3. So for example, the earliest date is 1, then the second one is 2, 3, 4, 5, right? And I'm doing this. I'm doing it actually here. So this is pretty cool about F#. So I want to get my data for X and Y. And so I'm getting the stock data, I'm mapping it, and I am subtracting the first date from the current date. I'm getting the value, how many days is between them. And my second, my Y data is the close price. And then I'm mapping it to array and unzipping to get this into 2 separate arrays. This is pretty cool, to do it with C#, it will be a little bit more lines of code.
There's like a tuple in there, basically.
Yeah, so here's a tuple. So this is like the first element, but then I am creating here I am creating a sequence from it, and then I'm creating array, and then I'm unzipping it into the tuple. Yeah, beautiful, right? All right, so and here I'm getting the target date. So I'm again calculating which number it would be, and here I'm using MathNet library, and they have a linear regression, the function that will calculate for you the linear regression, and I'm getting as a result the intercept and slope tuple here, and then I'm calculating the end result. Actually, I forgot to show you a little bit about data structures in F#. So let me go back here for a second. So when I was starting with F#, I want to create some more complex data structure than variable. So the first thing was okay, so how do I create array? So I was thinking maybe if I do this, and I will get array because I'm just playing, and I see I got a list, right? So I was okay, I look up, I see that the list is immutable data structure in F#. It's pretty cool, but then okay, how do I access? And that was a little bit hard because you need to say x dot 0, which is if you are used to C#, this is the syntax is just not comfortable. I wasn't comfortable for the first few days, but after a while I got used to. And then I see that it returns me 3 elements. And why is that? Because I actually didn't create a list of 3 elements. I created a list of 1 element, and this 1 element is 3-element tuple. So in order to create a legit list, what I have to do is I need to use semicolon between the numbers. So here I have a list, and here if I get the first element, I get 1. If I get the second, I get 2, and third, I get 3. But then I wanted to modify something, right? And of course, first attempt was not very naive. This will not work, as you probably know already. So then I try, maybe I can use this uncomfortable assignment sign. I cannot do it neither. So then I look up, and it turns out that if I want to have mutable collection, I need to use arrays. So then if I create array, which is very simple to list, but you need to do it like that, which is even more uncomfortable. It's array, right? And then I can, of course, access it. And I can also modify this. Modification works. So if you want to have mutable collection, use array. Immutable, use lists. Usually, the list should be good enough because, again, you shouldn't modify the variables. You should rather map and do stuff like is done here when I am just using mappings here and converting data, because that's what most of F# algorithms are doing. And usually, if you want to do some iteration, you can use recursion, and behind the scenes, the F# compiler will make sure that this is efficient for you as well. Okay, so yeah, so here's this function, get estimated price for date. And here I also created like some sort of randomization, like 5% plus minus, to sort of give it like more real. And you'll see later on in chart, it will actually create some very nice range. And here I have get estimated price for date range, and here I have get estimated price for date range with random, which means I'm not only estimating one date, but I'm estimating all dates from, let's say, now to some target date. So let me show you really quick my tests, because I also have written tests. So in F#, there's a bunch of test frameworks. You can actually test your F# libraries with C# using XUnit or NUnit. It's not a problem because, again, you can use F# without any problem from C#. You can also use XUnit in C# code, like I'm doing here. You can also use FSUnit, which is like this cool syntax framework. So you know what I'm saying here, that first key should be type date time, and I'm checking this type in this not very verbose way. And here I'm using XUnit inline data, so I am testing if the number of results for like particular date ranges match. Here I am doing similar thing. I'm just checking if my estimate with random is like within the margin of 5%. And here I am just asserting this with FSUnit, and it has this cool thing called equal within. That means that some value needs to be within the range. And here there is a cool thing. So there is this other framework called FSUnit is asserting this. There is this not framework but approach called property-based testing. So what I am doing here is I am testing this function against 100 random numbers, and how the random numbers are chosen is get some 100 randoms from some range for me. And the way how we can do it is like, for example, this commented way is saying, hey, give me numbers that are type of days. So, and this type is defined here, which is basically integer within a range for greater than 0 and less than 365. So from this 365, give me some range. And the other thing how we can simplify it, if you define date property attribute in this way, then you can just use this. That's what I'm doing here. And this will generate a parameter. I call it odd days. This will be my parameter. How many days to add from now to get the target price. And then here, I'm getting the target day, date time now plus add days. And here I am saying, hey, look back 1 year. This is constant. And here I'm getting estimated price and estimated price with random, and I'm checking if it's equal within the 5% margin. And here I have some other tests. And let's run it really quick. Let's see if it passes. So run all my tests. It probably will recompile my logic project, and it will run every test. And you can see that this test that I was talking about, that is checking within the range. Well, come on. So, can we make it? Oops, does not work, but that's fine. When the test will start running, it will you will see it will stuck at one test, because this test will take much more time, because it's testing it's basically running this test 100 times. Also, the way how it works is it run it 100 times, or it run it until the first failure. So here we go. No, I cannot do it. Okay, never mind. Okay, so that's probably this test. Let's see if it's gonna pass. It probably should pass, I hope. Okay, and I have all my tests passing, and I think there was this one or this one. Property style, yeah, so it's this one. And actually, Visual Studio is not showing it properly. It's showing that it took only 1 millisecond, but it actually run this test 100 times. So if I wanna, for really quick, I'm gonna break this. So if I say get estimated price with random, here I'm gonna say if for date minus date time now, and dots total days. Oops, extract this. Total days, let's say, is less than 10. So for first 10, then return float 1. Okay, so and else do what you were doing before. And what's the problem here? It's okay, so I need to actually map this to integer, because I want to round this down, because it will return a float, which is a fraction number. Okay, so now everything is fine. Now, when I run it one more time, it should give me wrong values, of course, because the MSFT stock price is now somewhat around 60, so it should return something within this range based on the algorithm. And this property-based method of testing will start randomly choosing the 100 numbers from trying to 65. It might happen it will not choose 1, 2, 3, 4, 5, 6, 7, 8, or 10. It will happen because this is very useful when you're testing against some very, very large number. Like, for example, if you are checking if your, I don't know, some date time behaves correctly. You cannot test all dates because it will take too much time. You need to just choose some dates to test. And you can see here, I have actually a bunch of tests failing, but this one is saying that it failed actually after one try, which is very unfortunate. Sometimes it can fail after more tries. Yeah, it failed after one try. But what if we say less than 5? And it might fail after more tries. It depends, right? So it's just one cool way to test a large set of data. Okay. Now, yeah, sure.
Is what you're trying to do take the history of stock prices
and
then fit a linear regression line to those?
Yep.
Okay, so your machine learning does not then change it so that it was non-linear regression. It doesn't choose the model. It's merely finding parameters for a linear regression model.
So here is just simple linear regression. We'll get to machine learning like the second step.
Okay.
So for now, we have just the simplest linear regression algorithm. All right, okay, let's see now. It failed, and yeah, again, fail after one. So bad, but revert that. So I have this this logic here, and I have tests for that. So now all tests should pass when I revert it back. And I have this web API here, and I will actually try to run this. This web API is written using F# Suave Framework. It's very lightweight F# server. It's very good for like again small APIs. Okay, cancel. Let's just take a look. It's one file using a lot of libraries, but don't worry about that. So here I have a like helper function to convert to JSON. Here I have some methods, but the actual server is here. And I'm also using helper to set the cross-origin request headers, so I can use it from my other web app. And here I have a few routes, like get price. I have get price for date range, and this is what we are most interested about. And this function here, this is a pretty cool way how F# is using the pattern matching. It's sort of like a switch statement in C#. And here I'm basically parsing a query string, and I'm getting the ticker, I'm getting the till value and since value, because there are like 3 query string params. And here I am calling get price for date range. Oops, sorry, which is here. And this function is calling my logic, which is defined this different project. So let me run my web API, because now I see all my tests are passing. I'll run the server, and I will run my web UI. The web UI is written in ASP.NET Core, but actually I'm not doing anything very interesting here, because I'm just serving static files. And ASP.NET Core is pretty fast server to serve static files without much middleware. And I'm using Aurelia framework for a front end, and D3 to draw a chart. So let me, where's my cursor? Here, okay, let's run this. So here I have my server running, and I'm running basically another server. And this server at the beginning is doing requests, trying to get estimates for Microsoft stock until December 10, 2016, based on data since January 2015. So you can see it will decline if I get this as data set. What we can also do, we can check other stocks, for example, Google. Let's see what will happen in upcoming days for Google. Oh, it will pretty state. But you can also take a look what will happen for, let's say, next year. So I will go to November 7, based on, again, last year and a half-ish. So this will take a little bit longer. I need to do a few optimizations to don't do unnecessary requests. But let's see how the Google price will progress since today. Okay, come on. And here, actually, I added a little bit of logging. So in the console, it's saying that I'm trying to get the prices. And once it prints done, it means the request came back from the server. Oh, it takes a little bit longer, but I have no errors. So, okay, done, and cool. So you can see that the Google price will very likely go up, which has actually happened for a few last years. So yeah, you can buy Google stocks. Let's see what will happen with Amazon. Amazon is doing pretty good, right? Like last 2 years, it doubled. And this is awesome, actually. Microsoft is okay, right? It's okay. I don't know. Anybody has like Amazon stocks or Google stocks here? Anybody? Nobody? No stocks? Whoa. We should buy some. You see? I mean, I'm not from Amazon. I'm from Microsoft. So actually, I should tell you buy Microsoft stocks, right? But unfortunately, this algorithm is saying different things, so cannot convince you. Okay, takes a little bit long because you need to do all these requests to get all the data. And actually, what I didn't optimize this to do just one request. I am doing actually one request per every day in the future, which is not the best way to do. Okay, come on, Amazon. All right, cool. So Amazon will also grow. So let's also see what will happen with Apple. Did you guys see the new Macs and new iPhones? Do you like it? So? Is somebody planning to buy a new Mac? Nobody. So you'll still, like this, the icons thing, this touchpad. I don't know about that, but actually, it's pretty cool that now you'll just need to have like extra. You have just one USB port, right, in the new Macs, and you need to have this one converter, and you can connect everything to one converter. Because currently in Mac we have a bunch of ports. So, for example, if I'm taking my Mac, I go somewhere, then I come back to my desk, and I need to connect everything like 1, 2, 3, 4, 5, right? So now I'll just have this one connector. Oh yeah, so yeah, don't buy Apple stocks. So you see, probably happen after they release the new Mac. So no, cool. So this is a very simple way. It's basically estimates based on the past. But when we have this big amount of data, we can also use Azure Machine Learning for that. And to get started with Azure Machine Learning, you can go to studio.azureml.net. It's Machine Learning Studio. There's a bunch of tutorials on the internet how to get started. I will show you the links at the end. So here, oh, come on, I need to type it. Hope I remember. Okay, I remember. It's so bad that now like almost every website get hacked. I need to change password to have like different passwords on every website, and you have to remember it. It's terrible. I just got email that some other website got hacked. Actually, do you guys know this Have I Been Pwned site? You can check here if you like your email address got hacked. So for example, if I check mine, oh no. So 00 web host, the Dropbox, LinkedIn, Last.fm. Oh my god, I didn't even know about that. And the worst thing is like for example, it got hacked in 2012, and they just tell us like 4 years later. So bad. But it's pretty cool. Like if you register, you even get the notifications telling you, hey, like this service got hacked. Change your password. All right, so machine learning. So here, basically how it works, you create an experiment. So if you click new blank experiment, you can create this experiment. So for example, here I have a MSFT experiment. And what I did here, let me zoom out a little bit. So I just download this CSV with historical stock prices. And then I added, like you just basically drag and drop here. I have a task saying select columns in dataset. And here I'm selecting only close price and the date, because that's what I only care about. And then I'm saying split my data into 2 data sets and take 90% of data and try apply linear regression algorithm on this 90%, and take the 10% randomly selected and try to check how good the linear regression that you calculated on this 90%, how accurate is that? So like here, if I click evaluate model on evaluation results, if I click visualize, you can see that the average error in my estimation, it's 22. Which is rather large, because like current prices again like around 60. So if I tell you like, oh yeah, tomorrow it might be somewhere between 40 and 80, it's not very useful, right? So so this is not the best. But here I am using data from 1986. So I also created a different experiment that takes data from last year or last month. So let's see, for example, based on the last month data from October 4th to November 3rd. Here, if I see evaluation results, my error is only 1.2, which is not bad, because I can tell you like, yeah, the price would be sometime between 60 and 62, which gives you some better idea, right? So, and then when you have this experiment, you can create a web service. The web service that later on you can call and get the results. And here I already deployed the web service. So this is the way how you set it up. So I have my data, where I am selecting columns. And here is my web service input. I just call it input 1. I was a little bit too lazy to call it date, but the date is my input. And then it's taking this my experiment I had, the trained model actually, and it's trying, based on this trained model, to estimate the price for the future. And the output is called output 1. You can, again, configure it. And then if you click deploy web service, it will create web app that you can call using RESTful calls. And here on the left-hand side, I have my web services. So you can see I have 3 different. And for example, let me click this one based on last month. All of them are the same. And if you click on new web services experience, there is a instruction how to call it. You have like API keys. You have the parameters you need to specify it, and you even have examples how to use them. So here in consume, so there's like primary key you need to use in your call, and if you go to Python, you can see here. So this is like your payload, and here there's a URL, and so on and so forth. And you also need to headers need to set up this API key. So that's what I did in my Suave app. I created this method called get price from Azure, where I'm again, this is like a cool function to do this pattern matching in this way instead of doing very nested pattern matching like I did earlier. So this is actually one gentleman from Reddit suggested this, so I'm using it. And here I have just array of 3 experiments. So this function actually takes 2 parameters. First is the date for which I want to get estimate, and the second is the name of experiment I already have created in Azure Machine Learning. And then it's calling this web service. Here I'm using HTTP request string method, and I'm providing the URL. I'm providing the headers, which has authorization token, and the content type I accept. And this is my payload with my inputs, which one of parameters is date. And I converted the result to JSON. So if we go back to my web UI, which is here, there is this tab Azure Machine Learning. So here I have 3 experiments. So the first one is based on the data from 1986. So if I try to estimate for, let's see what will be next week, maybe. So get price. And it will be 27. So now MSFT again is, what is it, 60, right? So that would be very bad, right? The stock dropped that much, right? But again, this is because I'm basing on data from all over 30 years. But if I will base on data from last year, of the same estimation, I get 54. That's much better. Still, drop, but it's better. And if I estimate based on the last month, I get 58, which is even closer, right? So then another problem with machine learning is how to choose your data set, right? Like what data should I take into account when I am calculating something, right? Like for example, when you do polls for elections, right? How you choose your data, right? And everybody's saying that every method is wrong because like calling people is wrong because like, usually only older people have phone, younger people doesn't. And then some people are saying, oh, but in some states, like people will not really tell you who they gonna vote for, so on and so forth. So, right. So there are different challenges, but there is a lot of room for improvements. And even here on the Azure Machine Learning, if you go to experiments, you can see there, I just used the basic algorithm, which is linear regression, but there are different, say regression, but there are different algorithms. So for example, you can try to apply a few algorithms and then take average, or let's see, maybe like 5 algorithms will give you similar data, and like 3 other will give you different ones. And actually, this pretty funny story. Netflix, a few years ago, they created a contest, and they tell people that if you create an algorithm that will improve the recommendations by 10%, we'll pay you $1 million. And then there are different teams trying, and there are some teams who managed like to improve it by 6%. Next year they managed to improve it by 7%, but they couldn't get to 10. And then 1 year they're like, hey, let's join forces with all other teams and let's do all our algorithms and let's do it together. And then they managed to exceed this 10%. I think it was like something like 11 or 12 even. But then Netflix were like, oh yeah, congrats, this is your price, $1 million. But it turned out that they couldn't actually implement that because the algorithm was so complex that it will not make sense to use that much computational power to do all these calculations. So it was a little bit like throwaway algorithm. But this is interesting. But the power of computers is growing every day. So we can do more and more because also more data you have, which is also growing. More data you have, the more accurate your prediction will be. All right, where are my slides? So this is just I just started this project recently. It's very early stage now. It's just one algorithm. I didn't even deploy it yet, so I had a plan to deploy it actually to Azure. And I look at 3 different ways how we can deploy it. So you can deploy your F# apps with a library called Faye, and Scott Hanselman did a nice blog post how to do it. You can also deploy it with Docker. You can create your image, set up the F# there, and run it. And very cool way is also Azure Service Fabric, which is very good for microservices because here I have actually 2 services. One is this web API, one is this web UI. So I will choose one of these 3. Didn't decide yet. Another thing, I want to add more algorithms. So for example, there's this interesting boosted decision tree regression, which is basically what this algorithm is doing is taking the past data, is trying to predict, and every day I'm checking how good my prediction was, and it sort of self-corrects itself. Neural networks, decision forest, and there's much more. Oh yeah, and I also want to make the UI beautiful. There's a lot of JavaScript charts now. Oh, that's actually better, right? And some optimizations. I also was thinking about doing this in real time, so like you can, when you get like price updates in a day, you can see how prediction will change based on the changes. So that's like to-do list. Okay, so like a few websites how we can get started with F#. So the first link is actually my blog post where I put all the materials I found useful when I was learning F#. So if you go there to JJ09, getting started with F#. So here is some stuff for the beginners. So very good Pluralsight class, F# Jumpstart, which is only like hour and a half, and will give you idea what it is. And then like try F#, the site I showed you. The functional cones, it's pretty cool because this is like GitHub repo with a set of unit tests. You run the unit tests and all of them fail, and then you need to fix your code in order to have passing tests. That's pretty cool, right? And more deep dives like this, it says F# for beginners. But to be honest, this guy, Saka Barber, he's going over like every F# feature, and it's explaining, like, for example, performance implications of lists and arrays, so on and so forth, when to use what data structure and why. And so a bunch of materials here. And here's a little bit about testing, the property-based testing, which I showed you how to generate the random properties. A little bit about web development, how to use Suave Framework. You can also build your ASP.NET apps with F#. It's also possible. You can also build your Xamarin apps with F#. There's this guy, Frank Kruger. Frank Kruger. He built a pretty cool apps. One of these apps is Continuous, which is a C# and F# IDE for iPad. It's on App Store. It costs $10, and I would buy it, but I don't have iPad, so I didn't yet. But he wrote it with F# using Xamarin. He also written Calca. This is another project of his, again written in F# for iOS. And Calca is free, so you can download it for free. I actually play a little bit with that. You can, you have like the beautiful charts here. It's pretty cool. Okay, where I was. Okay, yeah. So the more materials, try F#, F# cones, F# org, F# for fun and profit that the gentleman recommended. And there's also, if you're familiar with ASP.NET, there's a tutorial called Music Store, which shows you how to create like simple music store website. And one guy ported this tutorial to Suave Music Store, which is doing the same thing using the Suave server. And there's also a very cool site, F# cheat sheet, which shows you, like, for example,